Hello everyone and welcome to our session. Today I will be discussing switches. Now, what is a switch? A switch is a piece of wire, as simple as a piece of wire that will move or alternate between two states. Now, the first type of a switches is an on-off switch. This switch, it either will open or close the circuit. Now, if we look at this type, the arrow is directed toward the wires, toward the circuit. That means it closes after the time 0 or at the moment time equals 0, like after the 0 with a partial of second. So if I will be asked to find the state when t less than 0, it was directed toward the tail. It means open, off, there is no current is flowing. Afterward, toward the head, so it's closed. For this scenario, it's the opposite. Now, before this time, originally it was at the tail side, so it was closed. And then after this time, when the time 0 came, this switch moved that way. That means at time equal 1 or 2, it's open. There is no current is flowing. Let's take a real example and see for ourselves. Now, for the given circuit, sketch the circuit at the given times, t1, 3, 6. Now for part A, at t equal 1, I'm given here 3 switches. If we're taking the time t equal 1, I want to compare the 1 with the 0. The 1 is greater than 0. That means if I'm greater than the time here, the time written on the switch, that means I'm directed toward the head. So the head is directed toward the circuit. That means it will be closed at this time, right? Okay. Now the 1 is less than 2. That means the switch should be directed toward the tail. The tail is toward the circuit, right? So originally this switch was here, and then at time equal 0 it opened. At time equal 2 opened. At time equal 0 closed. This one at time equal 5 closed, but I'm at time equal 1, so I did not reach this time, so I'm directed toward the tail. That means it's open. You see? So it's closed, closed, open. Let's go to this one, and then you can erase if you want those things, you see here, so it won't confuse you. Now, sorry, this is open. For this time here, t equal 3 seconds. 3 is greater than 0, so I'm still toward the head. At time equal 2, the switch opened. I'm at time 3, so I'm past this time, so it means to the head, it means it's open. And the 3 is less than 5, that means it's directed toward the tail, and the tail is away from the circuit, open. For the time t equal 6. For t equal 6, 6 is greater than 0, so I'm toward the head. 6 is greater than 2, toward the head. And 6 is greater than the 5, so toward the head, right? Again, at time equal 0, it closed. I'm at time equal 6, so currently I'm at time equal 6 after the time 0, so this switch is closed. This switch is opened at time equal 0, so I'm past that time, then at the open state. Time equal 5, it closed. At time equal 6, it passed this time, so the switch is closed. And this is the first type of the switches. The second type, it does not do an on or off mission or objective. The objective of this switch is to move between two nodes. Like imagine a node, alright? This is a node, and this is another node. It might have its own current or whatever, and there's a switch here. This switch would either be connected toward here, so this circuit will work, or toward the other side, so this will be not working, and this circuit to the right will be working. And this is the node switch. If the time is less than 0, and since this switch will work at time equals 0, so before the 0 it was toward the tail, that means node A is connected, so this loop will be connected. Afterward, t greater than 0, it will move to node B and this loop will be closed. Now this is our like last words in this video. I want to just say what we'll be taking next class. We will be talking about some tricks that usually professors would bring on the exams, and then I will be solving two problems on the parallel series switches and the tricks combined together. So bear with me and I will see you next time. Bye.